Okay, so this is a kind of short introduction to the assignment. The assignment, like I said in class, it's a two-part assignment. It's going to be worth more than 2 assignments would normally be worth. You should consider it as like a take-home exam. So I'm asking you not to work in groups and try to work by yourself. So in order to complete the assignment, you will have to make an account on this service, which is a free modern math software developed at University of Washington at Seattle. So go to cloud.sagemath.com and create an account. When you create an account, you'll see this page since you have no projects, and you can create a new project and give it a title. So maybe assignment 7 and put your name. You can keep it private since if you keep it private, then what you'll be able to do is you'll be able to share the project with me, and then that'll be the way that you can submit the worksheet to me. So you create the project, and then you'll see the project listed here, and you can click on it. But when you do that, there won't be anything in the project yet. So what I'll do is on the web page under assignment 7, you'll be able to download a starting worksheet, and when you download that, then you'll be able to put it here. So here you just click on create, and you would normally create a Sage worksheet here in order to work with it, but I'm going to give you one so that you can just upload the initial worksheet. So click here, and then this will be what it's called, PMU199-2013. That's the thing you'll download from the web page, and then it'll be there. Okay, so now you should have a file. So if we go to files, then it'll be there. The worksheet is there, and we can click on it, and then we see the worksheet here. So this is the worksheet that I made for this assignment. Okay, so let's just look at this a little bit more carefully. So basically this worksheet is like a calculator which is divided into sections, and the sections are these horizontal lines. So this is the first section here, and then this is the second section, and so on. And if you want to make more sections, you can just click on one of these lines, and you'll get another section here, which I can put some arithmetic, for example. And anytime you want to see the answer to an operation, you click on Shift Enter, and it'll give you the answer right there, like 3 + 4 is 7. Shift Enter, and it'll output the answer. Okay, but for now, let me just delete this. Okay, so the first section is just a setup, which is not really important. The most important thing is here, this number. This gives the amount of precision that the rest of the file will use. So you see down here, for example, there's I can't tell, there's like 20 or 25 digits of precision on this number. You can increase that by just increasing this number to something higher, and you can use as much precision as you want. It might be useful for the later part of the assignment to increase this number, but for now let's just keep it at 100, and and so run. So each section you should just run it by doing click and Shift Enter on it. So that will run that section. Okay, this section is basically defining the function that we're going to iterate. So here this just means define a function which is called f, and the input is going to be x, and it's defined, well, this is just describing it. What is it going to do? It's going to return the input squared minus 0.1. And if I do Shift Enter, then that function is defined. So now we have the function f, and we can use it for different things. So here what I've done is I've written f of 0. So I'm looking at the output. If I plug in 0 into the function, what do I get out? If I do Shift Enter, it'll give minus 0.1, which is what you would expect since you're just squaring 0 and subtracting 0.1. Okay, so then you can type out any kind of any combination or a composition of the function. So I could apply, let's say I wanted to do another one, f of f of f of f. Then I do Shift Enter, and it computes all these values. So this here, you see the first number is the f applied to 0. This is f applied to f of 0, and so on. This is f, f, f on 0, and all the way down. So what you can see here is that when you keep iterating, you'll notice that, well, okay, first it gives me 0.1, then 0.09, and then after that it gets a little bit, so it's very close to 0.09, and seemingly it seems to kind of be stabilizing to something that's around 0.916, right? So it seems to be getting closer and closer to some actual value. So if we wanted to investigate that and see, where is it actually going in the long term, then what you would like to do is iterate many times, and since we have a computer here, we can iterate as many times as we want. So let's say that we wanted to iterate 20 times. We'll just set n equals to 20, big N. And then we're going to create a list, which is called Iterates. So this is just the name of a list. And I'm going to start out, so list is just something that's in square brackets, usually separated by comma. So, something like this would be a list of 4 things, 4 numbers. But I'm going to start out with just one single thing in the list, which is 0. And then, after I've made this list, then what I'm going to do is I'm going to cycle through, and I'm going to, so range n is just, so let me just show you what range n is. So if you put just range n, range 20, let's say, then range 20, it's going to output a list with 20 things on it. 20 because you start with 0 and you end with 19. And so this means that, you create a list of size 20, and then for every element in the list, you're going to do something. And so that means that you're going to do this operation 20 times. And what it does is that it takes the list, iterates, and it will append or add to the list something. What is it going to add? It's going to add f applied to the last element of the list. So this here is a fancy way of saying, what is the last element of the list? So for example, here, if I said square brackets -1, this would just extract for me the last element of the list, which should be 19. And if I do Shift Enter, it indeed takes 19 out. If you compare it with, let's say, 0, that will give me the first element of the list. This gives me the second element of the list, and so on. But actually -1 kind of wraps around and gives me the last element of the list. Anyway, the point is that it'll take the last element of the list, apply our function to it, and whatever the result is, it'll put it at the end of the list. And so since it does this 20 times, it's going to make the list a lot longer. And then once it's finished this, what I've asked it to do is to print it out. Print out the list. Okay, so if we do Shift Enter on this, then you see the list down here. It starts with 0. Okay, that's just the initial seed value for the iteration. And then we apply f to it, and we get minus 0.1. Then we apply f to that, 0.09. As we saw up here, it's the same result. 0.919, right? It's the same results as up here, except that now we've done it 20 times. And if I wanted to do it more times, then I could just put 40 here, or any number, and do Shift-Enter. And there you see all of the values, okay? And you can already see that it's really approaching, the more times we iterate, the closer that we're getting to a certain value. And so that's part of the question of the assignment is, what is the value and how is it approaching it? Okay, let me just change this back to 20, just this output. Okay, so anyway, the point is that now this section of the worksheet, what it does is it makes a list of all the iterates. And let's say that you wanted to visualize this iteration. So we wanted to, let's say, plot these values. So actually that's very easy to do. So what you do is you take each of the elements of the list. So what this symbol here, iterates I, that means the ith element of the list. And so what we do is we make some points, some xy points, where x is I is the first or the second or the third element of the list, and this is the actual value of the iteration. And so we get a bunch of points, right? And then we use this this operation called point, and it just makes a bunch of points out of all these values. And so the output of this, so if you do Shift-Enter on it, it'll produce this graph. And here what we can see is that so this axis is which step you're on. So at the 0th step, we have the value 0. And then at the first step, you see that the value is minus 0.1. The second step, you're at something a bit higher. And third step, it's a bit lower, and then it goes a bit higher and lower, and then it seems to stabilize, And again, if I change this n to 40, say, right, then that changes the iterates list to be much longer. And then if I now do Shift-Enter on the visualization section, then you see, well, we get a whole bunch of points here. We get 40 values. And so you can see really how it stabilizes like this. The long-term behavior is that it approaches a single value. Okay, and it may be that in your experiments, you might want to do the iteration for, let's say, 1,000 times or 10,000 times. And in that case, you may not want to graph all 10,000 of the values. You might only want to graph, for example, the last 10 values or the last 5 values. So here in this section, I'm showing you how to graph only the last certain number of values. So here what it says is that make a bunch of points for the iteration, but only let I range from n minus 5 to n. So if n was 40, you would get like from 35 to 40. That's the range for the graph. And so you would only get 5 points. If you wanted the last 10 or the last 16 or 20, then you would do the same thing. You would just put 20 here. And that's it. So each section here would be useful for you to complete a different part of the assignment. So if we look at the assignment now, basically what I'm asking you to do is to study this iteration for different values of c. So the function is x squared plus c, and I'm asking you to change the value of c. For example, in part A, I'm asking you to take several values of c between these two values. And so what that means is that you need to go to the worksheet and you need to change this value of C. I took C to be 0.1 for the demonstration, but you have to change that value to various different values, and you need to look at the iteration for the different values. And what you can do is you could so you could change the value of C and then use the worksheet to see what happens to the iteration in the list here or in the graph. And you can always take these graphs and save the images, and then you could put those images into your assignment to submit, for example. Or you could just copy these values. If you find what the long-term value is or the long-term behavior, you could just copy and paste it into your assignment. So what I want you to hand in is your worksheet that you used, and also all of the answers to the questions should be in the Google Docs document, or in this document here. And so what you could do is, as you work on the worksheet, if you find some good results there, you could just save them or copy and paste them into your Google document as you go along, for the different parts. At the end, I'm asking you to summarize your observations and to speculate about what is going on. So try to come up with some kind of theory or idea of what it is that, something that might explain the behavior that you will discover when you go through the different parts. I also expect that this will probably take you, maybe a couple of hours at the most. But as you go through the sections, you will find some strange behavior and strange results. And don't forget that you may want to do this iteration for a large number of values. In order to see the patterns that will come out, you may need to do a lot of iterations, and it may be helpful to increase the precision of the numbers, which is all the way at the top. And also remember that you have to run each section one by one, because sometimes the section depends on some value from the previous section. And running is always Shift-Enter, or you could also use this play here to execute the current cells. Last thing I'm going to say is that all of what you see here in the worksheet, the language, the computer language that's being used is Python, which is a very widely used language, and it's useful for you to see it at least once in this class. Okay, so have fun with the assignment.